Hey YouTube, Joja here from Tipsy Python, your casual guide to learning Python, and I'm back with another video. The goals of today's video are: one, we're going to familiarize ourselves with some collections data types from Python, particularly the list data type, and we're also going to go back and refactor that sales tax calculator that we started in the last video, and we're going to add some functionality to persist a history of inputs. And today's video is brought to you by Four Roses Single Barrel Bourbon. I was tempted to make some puns about this one, but I always see people posting with it anyways, like 3 bottles of it, and they're like, I got a dozen roses. But anyhow, I felt that this one was appropriate coming off of the Blanton single barrel last time. This is another single barrel bourbon. It's actually proofed at 100, which is my favorite proof for bourbons. Anyhow, get your fingers ready, get your computers ready, get your drinks ready. Let's do some coding. And I'm starting off in my Jupyter notebook. Y'all remember this guy from last time. We talked about the list data type. Now, we didn't go in depth about it, but this is a really important one because in Python, the list is a collection. It's a container object that holds other types of objects. And if it sounds a little iffy at first, don't worry, this is gonna make complete sense in a second, because collection data is everywhere. Like, think about Facebook. Like, you have a collection of friends and everyone has a collection of posts that they make. No matter what programming you're doing, you're going to come across collection because it's almost like a naturally occurring data type. It happens everywhere, it's very common, and you're going to find yourself reaching for list a lot. Getting back to the code here, we can assign a variable, a list object like this, or another assignment method is just to use the function list, which also returns a list object. When you're looking at other people's code, you're probably going to see both of these used, but me personally, I reach for this first one a lot more because if you actually do use the list function, it does a calculation and then it returns the empty object. So why not just cut out the middleman and specify the empty list ourselves? Now let's do more than an empty list. Let's say I have a list. I'm going to reference a variable named prices that points to this list. Inside it, we're going to have 50, 100, 200. If you're coming from another programming language, you might be familiar with using arrays. Now, while array is available in Python standard library in the array module, the array.array object, people reach for list a lot more because it's a lot more flexible. But even with flexibility, it's structured. I mean, there's 3 main things that you need to know about lists. They are ordered, they are mutable, and they can hold duplicate values. For instance, here, I can print prices, and then I can tack on, let's say, a few others in here as well. Execute that, and when I reprint, we'll see that the list is indeed holding the duplicate values. And I know you're thinking, Josh, I could have guessed that. That's intuitively how this thing works, but just be aware there's other collection objects that don't work that way. For instance, a common one is I'm going to take this, copy it, and instead of the brackets, I'm going to put curly braces here. I have objects separated by commas. That works. Let's see, what is this thing? It's a set. The set object is a lot like a list, but if I print it out, you'll see the duplicate values have actually been removed. And another funny thing here, looking at the order, this doesn't even resemble the order of the inputs. So while lists kind of work in this, like I said, intuitive way that they're ordered and that they can contain duplicates, there's other collection objects that are used in specific cases that don't work that way, like set. Moving on though, this video ain't about sets, it's about lists. So I'm going to go back. I'm going to grab this list. It wouldn't make much sense if once we initialized a list, it just stayed like that. After all, the third property that I mentioned earlier is called mutability. Think about like mutation, the ability to change something. A list can be changed after we initialize it. It can be a living object that we're adding to or removing or making transformations on. Let's do a few of those because there's some very common helper methods that are very often used. The first one that I want to talk about is adding an object to our list. I'm going to use the append method. And after I run an append, we're going to reprint the list and see that the object has been appended to the end. And append only takes 1 argument at a time, but we can run it multiple times. So I'm going to run it twice and then a 3rd time. And if I reprint prices, we'll see that all those values have been persisted to the list. And I realize that I've just been using integers so far, but I don't want you to get it twisted. The list is agnostic to the data types that are going inside of it. We can put anything inside of it. For instance, here, I'm going to append something else, maybe a string like A. We'll see that A gets appended. I'm going to append a Boolean like true. It goes into the list, no problem. And A, just to show that we can, inside the list, I'm going to put Yeah, that's right, another list. Now granted, if you jam up your list with all these weird data types in there, it may become unmanageable. So it's good practice to try to keep things orderly, but it's always there if you need it. You can put anything you want inside the list. In the same vein as append, there's one that goes hand in hand. We can take things on the list and we can also remove them. You'll notice here that the remove method only removes the first matched instance of an object that it finds. So if I want to remove all of my 50s, I have to run this a couple more times until they're all gone. In the same vein with remove, there's one more method that I reach for really often that also removes objects from the list, but it works just a little bit differently. This one's called pop. I'm not going to pass any arguments into it, and it returns a value. So let's check out what happens. When I called pop, it took the item at the end of the list. The method removed that item and returned it. So here I printed the item that was removed, and then when we printed the prices object, we have it without the last item on there. So again, getting at that property of mutability, the list object is able to be changed in place. We can update it. Just to illustrate this a little bit more, I'm going to run it a couple more times. So I'm popping the last item that was on the list. It's true. True's been removed and it's no longer there. I'm going to run it again. The pop method returns A, and the list no longer has that value. And as if that wasn't enough, I got one more gotcha for you. Let's go back to the pop. I didn't pass any arguments before, but let's add something in. I'm going to say pop 0, and let's see what happens. Ah, the object at the beginning of the list, 100, was returned from the pop method, and it's no longer there. Now I realize if this is your first time looking at the pop method, it seems a little fickle. Like if there's no arguments, returns what's on the end, and if you add the 0 argument, it returns what's on the left side. But what happens if I put 5 or 18 or some other argument in there? That's a good question, but first let's talk a little bit about index. Now index is just a glorified term for position. An item's index in the list is its position in the list, and index is very important to the ordering. Let's explore this a little bit more with code though. I'm going to take a list item called things that holds some values. And the first thing I'm going to do, just to kind of show folks that there's a really nice function called len, which just means length. If I do something like length of things, it returns the number of objects inside of the collection. But what I'm really interested in doing here is doing something like this, taking 0, which is actually the argument that we put into pop, and you'll see that we're actually referencing the first item in the list with this bracket notation. Now, an important thing about index is in Python and many other coding languages, items are 0 indexed. They begin with 0, but then the number just increments after that. 0, 1, 2, 3, 4. So incrementing here, the 0 index is letter A, the item in the 1 index is letter B, and so forth. Another cool thing that I can do with this bracket notation is I can actually do what's called a slice of the list. So if I want to take something, let's say, that starts at index number 0 and ends with index number 2, I can do that and just get a couple items out of here. And another important concept, going back to that property of mutability, is the idea that I can reference a position in my list and I can actually set it equal to something else. And this is one of those really nice intuitive things about Python, is that the list can be manipulated, mutated, if you will, very, very easily. And again, that's not the case for every collection data type. If we look at another data type, I think we remember this from the first video, there's one called tuple. Actually, it works a lot like a list. So I can make a tuple using the parentheses on each side instead of brackets like I would for a list. And then I can reference items with this bracket notation. But what I can't do is change a tuple. Python actually throws a type error. It says right here, tuple object does not support item assignment. Tuples are another collection type in Python that they're very similar to lists in a lot of ways, but they're read only. We cannot update a tuple in place as we would a list. And I get that that seems a little silly, especially if you're a beginner, but trust me, there's certain use cases where it makes sense, where maybe a data item like a score that increments as we go in a program, it makes absolute sense that that will change. But other items, let's say height of a person, is pretty fixed. It's probably not going to change, and data types like that would be a good candidate for tuples. Now that we're starting to get kind of familiar with these collection data types in Python, what do you say we put something into practice? So let's go back to that sales tax calculator that we started last time. I still have this guy right here. I'm going to edit with Sublime Text. Now before I start editing this, let's just kind of talk through conceptually what's the requirement that we're coding to here. I think a good feature that we could add would be to keep a running total of prices that are input, and then we can return them like a history input feature.
Just a little something to do with.
All right, I'm ready to code. First thing I'm going to do is initialize a new list at the beginning of the script. So I'm going to say price list equals an empty list. And then as we go through this loop, as the user is inputting prices, we need to add prices to this list as we go. We can probably use the append method that we talked about earlier. So as I'm looking at this as well, I feel there's a few things that we can do. First, I'm going to do a little refactor. I'm going to convert the input to float in one line, so we can remove a line of code here. Also on this tax rate, instead of adding one to it later, I was just kind of demonstrating the arithmetic. I'm going to put it here. Now I'm going to say my total is the input price times the tax rate. That fixes the line I removed. And if we're talking about keeping a running history, there's actually something that's not going to change. Each time that the user inputs something, we're going to get an input price, and it's going to stay the same. It doesn't need to change. So maybe a tuple might be a good container to hold these prices. So for this iteration, I'm going to say this tup equals, I have my parentheses to indicate a tuple. The first position is going to be the input price, comma, the total. And no matter how many times this is executed in the user input prices, this particular tuple is going to stay the same. We're not going to go back and update it later. But what we are going to update is our list that holds all of the tuples together, that holds the state of our application. And for this reason, it's important that I define price list outside the scope of this loop where everything's happening. So price list is set one time. As we go, we're going to append items to it. Let's do that here. Price list append. We're going to append this tuple. Just to ensure that this is working, I'm going to say print price list after each time, and then it will reset. Let's check it out and make sure that it's working. Calculator.py, my item price is 88. I get my total after tax, and then the numbers have been added to a tuple inside of the list. Now let's keep it going. The next one is 60. The next one is 50. Next one is 15. All right, this is looking good so far. Let's add one more requirement just to polish things off, and we'll clean this up a little bit. Let's imagine that I didn't want to see the full history, but I only wanted to see the last 3 items that had been entered. Let's refactor our code to add that in. As we mentioned earlier, on a list we can do something called a slice, and I could say something like 0 to 3 to take the first 3 from it, but what I'm actually going to do is say 3 colon and -3. So starting from the end, I want to go back 3 positions and retain that output. And then just for formatting, let's clean this up a little bit. So I'm going to put a $sign here. Here I'm going to say, use a formatted string. The price history is, make it easier to read, I'm going to add a new line at the beginning, and I'm going to add a couple new lines at the end. And the output should be pretty formatted and easy to read by now. Let's run this one more time. The item price is 5. The item price is 10. Looking good. The item price is 20. The item price is 100. And as items are being appended to the end of the list, because we use that slice, -3 starting from the end, we're only getting the last 3 items that have been entered. And that's what success looks like. Doing a little programming and enjoying a little bit of good whiskey. Now, guys, I do want to say something about this Four Roses. Like I said, it's 100 proof, it's single barrel, which, candidly, this is really consistent for a single barrel. A lot of times in single barrelings, there's a little bit of variation between the actual barrels, but this one, Four Roses, does a really good job of keeping them consistent. The nose on this one is awesome. It's like cherries, baking spices, spearmint. And on the finish, it's all cherries, oak, and caramel. At 100 proof, this is a really robust bottling. I love this one. It's priced really appropriately. I mean, this is one that I can go out and just find. I don't have to sell my kidney to get a bottle of Four Roses single barrel. And man, it's delicious. Like, honestly, at the price point, king of $40. I'm just gonna say that right now. King of $40 right here, folks. And I don't even want to detract. You are the king of this one. You did a great job programming today. You made me proud. Now, next time we are going to double down on this concept of iteration, like this loop that we're using for the user to input data. How does it work? And how does iteration relate to the collection objects that we talked about today? We'll learn next time. Until then, friends, Tipsy Python.